Hello class, let's take a look at Chapter 2 in your CompTIA A+ textbook and some beginning concepts just to get started, just to have a foundation. Has to do with, in this case, protocols or rules, how we communicate and how that session is maintained for accuracy. UDP and TCP. UDP is, you'll see that for video streaming and voice over IP phones and things like that. And that has to do with a user datagram protocol, kind of an important concept. So it's okay to drop packets when you're using UDP. It's used for its uses for streaming information. So you can make sure that the transmission doesn't stop because you lost a couple packets. It keeps going. However, if you're sending an important email with an attachment, well, that better be connection oriented or 100% secure, that everything's going to make, all the packets are going to make it to the destination. So that's Transmission Control Protocol, or TCP. Very important concept. Most of the stuff we use is TCP, so kind of keep that in mind. Okay, so how do those communication methods get from point A to point B, right? What ports do they go into when they get to the server or computer? And that has to do with these methods of organizing that transmission, or the use of ports, to make things so they're not a mess. So you'll probably run into some of these on a test for the A+ exam. So file transfer protocol for sending files from one destination to another, port 20 and 21. Very important. Mail protocol, simple mail transfer protocol, is port 25. Now, just because the receiving computer sees a packet coming in for port 25 doesn't mean that's what the packet contains, right? So sometimes those ports, those names that are pulled off the part of the data coming through it, can be misleading. So many times the servers have other servers that we act as an intermediary type server that takes a look inside the packet to see, oh, is that what's inside the packet? If not, it gets discarded. If it's correct, it gets passed through the actual server. So those proxy servers have a job to do to police that communication. Now, the other one that's kind of important would be port 80, and that's going from web page to web page, or hypertext transfer protocol for web pages. And as an extension of that, another important one would be port 443, because maybe we're sending credit card information over the web page. So, this is a secure protocol for HTTP. And that is, the data is encapsulated, so it cannot be looked at and examined from someone that's on the network that shouldn't be. So this is file transfer protocol, and this is showing the prefix for is FTP versus HTTP for web pages. This is showing you what else? Telnet, SMTP is the simple mail transfer protocol. Let me go here. All right, let's talk about when you are looking for a web page, you'll type in, for example, Fresno City College.edu. Well, that's really not the name of the server you're going to, the web server. It's got a numeric address, or an IP, if you will, an internet protocol address. And you don't need to have that memorized, because your internet server provider provides the post office in the sky, or the domain name server, which functions as a post office in the sky that translates that web page address you can remember, Fresno City College.edu, to the numeric IP address, which is kind of neat, right? Now, of course, if you're enterprise, you're going to use something like Google for their DNS servers to get that information. DHCP has to do with giving an IP address to every node. A node is a device on a network, in a local area network, and usually those are set up. The network technician sets up a range of IP addresses that can be allocated out and delivered to every item or every computer, or not printer usually, but every computer or something in the local area network. And okay, there's a pool you can use, right? We'll let this many items on this local area network, but we're probably going to hard code the IP address for the printer, because we don't want that to ever not get connected, right? So it won't be that IP address is not included in the range that the DHCP, Dynamic Host Control Protocol server, Dynamic Host Configuration Protocol, which is a protocol that runs on a server, can use to give out an IP address to the devices, the computers are on the network. Like, well, we're going to give you a set of 50 you can choose from. And then once that's used up, it's used up. Can't get on the network unless someone logs off. But the printer always gets a static IP address, so it can breach. So that's something you learn when you set up networks. We talk about that. What else? I think I need to jump down here. Let's go to, all right, so that's a little bit about software and protocols and sessions and communications, TCP and UTP and ports. So let's kind of get into the network hardware. And we start out with a router. And what a router does is it connects, it connects networks together, like your local area network to the wide area network. That's the job of a router. That's what it does. And the SOHO is small office, home office, has to do with, well, there's a picture of it right here that talks about the different ports and back, the network cable, and this is actually a built-in switch in the router, so you actually can add a switch. You can plug a network cable from maybe you have an 8-port switch, right, into one of these 4 ports, and now you've gone from 4 ports to, let's see, not 12, but 11, right, because you used up one here. Now the switch is what connects all the nodes. A node is an item connected to a network. It's probably a computer or printer. It connects all the nodes to the local area network, right? And the job of the switch is to know the network card, the MAC address of the network card of everything in its little zone, right? All right, in a segment, if you will. And because when you go out and send, let's say you're going to a web page and it goes from the switch to the router, your local area network, and the router goes out to the World Wide Web and gets the web page you want, and it comes back, that page comes back to the router and then makes its way to the switch, and the switch needs to know what node, or computer in this instance, asks for that web page. So the switch knows the address of that network card that sent the request and delivers the web page to that computer. That's the job of the switch. It's very efficient. They're not that expensive. Now, that's for a switch handles all the wired devices or nodes on a network. But what about wireless devices? For that, you need a wireless access point, or a WAP, we call that. There are many types to choose from. They have different capabilities and frequencies they run on. I think we'll get that to in a minute here. Usually the firewall is hardware. It could be a separate appliance for enterprise development. Not probably. It is included in your SOHO router. It includes a firewall. Power over Ethernet. What that has to do is giving power and data connection to your wireless access point, because many times it's going to be placed and mounted in the ceiling, and in a business environment, probably on a shelf or counter for a home environment. But when they're put in the ceiling, usually you don't have outlets up there, right? So you have to make sure you have a device that can be powered with a network cable or power over Ethernet, and it has a device that goes into the switch that sends an electrical current on a few of those, a select few of the 8 wires on the network cable for power, and the others are used for data for the network cable. There's just different types of, depending on the distance of the run, you might have 70 watt, which gives you a little farther distance, and compared to, let's not go to the plus, let's go to 25 watt. Hubs, we don't see much anymore. They're not efficient. When you're in a local area network and you send information, request information from a computer, a node connected in that local area network, then when the data comes back, if you're on a hub, it gets sent to all the devices, all the nodes on a network, and only accepted by the one that is the correct MAC address or network card address. So it doesn't mean the web page gets shown on, let's say that you have a local area network of 30 computers. The web page comes back to just one computer that has to match the right MAC address, right? But there's a lot of busyness on the network because a hub sends it to everybody, and it doesn't need to. If it had a table and can keep track of all the network card MAC addresses, then it would be less busy. It would be less of a noisy, less congested local area network. So for that reason, we don't see hubs used much anymore. Network interface cards. Okay, let's jump to let's go into wireless, and let's talk about protocols and frequencies. The two big ones you're going to learn about is 2.4 gigahertz and 5 gigahertz. Now, they each have advantages and disadvantages, as the book says. Your slower 2.4 gigahertz can span about 160 feet, which is kind of nice, right? You know, especially if you have outside wireless access points. But you're in an enterprise environment, you're probably going to want to cover all the area that you need access for the people with a 5 gigahertz because it's just faster, many times faster. So the 2.4 gigahertz, 150 feet, but faster, but only 11 channels. The 5 gigahertz, 50 feet, all right? So you got to put, instead of one covering 160 feet, you need three. So you got to put more out there. But 23 channels, so it's faster, there's more channels, so you get less collisions, less overlapping on the wireless network, but a shorter range, right? The better wireless access points have more antennas, that support sending and receiving data, and that's what the 3x3 talks about. The channels has to do with what, for instance, a 2.4 gigahertz wireless access point has 11 channels, but there's some overlapping between the channels. So typically you set them up as 1, 6, or 11, right? So they won't interlap. If you got to put them closer together, you don't want, which is smart for better coverage, you don't want to use channel 3 for each one. You'll designate channel 3 or 6 or 11, and you'll have less overlap. So, and setting up those networks, we have a wireless networking class that kind of goes to that in more detail. Bluetooth, I think you know what that is. Wireless standards, probably important, and you'll probably get tested on this for the A+ test. So just to know that the 802.11.11, 802.11n has to do with the standards. I know that's a crazy number. Who thought of that? Well, a set of engineers that developed the standards thought of it, and once they, it comes out and it's fully accepted, then the manufacturers of the hardware know how to make that equipment and what wireless frequencies we have to design. And that has to do with interoperability, so you can use different equipment and blend it together. You don't have to use all the same brand equipment. So 802.11 can support 5 gigahertz, so just make sure it has that, and the multiple input and output antennas would improve transmission and reception of all the nodes, right? Those are items on a local area network, can communicate on that network. You're probably going to want 802.11ac, that's 5 gigahertz, so it's faster speed. You know, we're going from, there's a speed in here somewhere. We're talking about 300 megabits or 400, where is it, 433 megabits. It's faster, but you need more of them. And super fast would be 802.11.ax. So here's a good chart that talks about the pros and cons between them. So let's talk about services. So now, when you send a mail, it goes to a post office and it goes along its way till it gets it to the destination. When you request a web page on a computer, your internet service provider provides that, if you will, electronic post office in the cloud. That is, the cloud would be servers connected that you can get to from anywhere. And that server then translates that address you type in your web browser, like FresnoCityCollege.edu, to a numeric address, an IP address, if you will, Internet Protocol address, that would tell you, that would tell the information you're sending or requesting how to get to the server, right? You don't need to know that numeric address. Your DNS server does it for you, which is kind of handy because it's easier to remember FresnoCityCollege.edu than it is to remember an IP address for that server. Really difficult. Now, another big concept has to do with the file servers, and that's, in this case, this is Dynamic Host Control Protocol. That's a service that's running on a server that probably has multiple services like DNS server and file server. And what that does is, in setting up a network, is really manually intensive, and prior to DHCP, the technician would have to physically type in the IP address for every node, every item connected in that local area network, right? That's a lot of time. Or you can say, you know, for this segment of computers, you're going to go to the DHCP server, and it's going to give you an address out of a pool of addresses. It's kind of cool. It saves time. The downside, if you will, if you don't have enough IP addresses, and one item on the network, one node, like Mr. Printer, has to always be available, then you're probably going to hard code the IP address for the printer. Put it up high in the range of IP addresses available, and don't have that IP address included in the pool of available DHCP addresses. It's just a technique for managing your setup of a network. File servers, you probably have a device, in this case we have a network attached storage, or it could be a server itself that has file services running to get access to maybe the payroll department in a company shares files, human resource shares information on their employees. Those are centrally located on the server so employees can get to that. I worked in an IT shop, and we'd worked on projects together, and we have server locations for files that we need to have accessible at any time. These are all individual services that can run on a single server nowadays, and it's not as often you'll see them on a separate server. A concept which you'll learn in Security Plus class has to do with the AAA server, and when you're set up as a user on a network, you're given permissions to access information on the server, and based on your credentials, you may be able to maybe view HR files and look at your HR file, but not permission to edit those files. So that has to do with the security put into the server and your user credentials given to you as a user for what you can get to and what you cannot get to. It's a really important concept. Load balancers, legacy, Internet of Things is kind of big. It's becoming bigger and bigger because everything is an Internet of Thing. You do have to be somewhat conscious that there's home appliances, there's cars, there's for instance, I was given a digital picture frame, and it wants to be on my network, and I would guess it was a very cheap picture frame. It wasn't that expensive. I doubt a lot of money was spent on security for it. So it is an Internet of Thing because I could send a picture from my phone to that digital picture frame, but so could other people. And since I don't trust the security built into the software on that very inexpensive Internet of Things device, I don't put it on my network. I'm kind of careful about that. So keep that in mind when you look at Internet of Things. They're not always, they sound cool, but thermostats and light switches are probably more secure than, I don't know if I would do a door lock, than like digital picture frames. They're kind of less expensive. So let me keep going in here. Configuring basic wired and wireless small office, home office network. So this talks about the IP address, and this is an example of an IP address, and this is a very common one, 192.168.5.1. Now the subnet, let me talk about this. The subnet mask has to do with a way to identify, in this case it's right down here, a way to identify what's the network portion of this address and what's the host portion, right? It's a way to segment the network and say, well, this is part of the network, and this is this fourth octet here, right? That's 0 has to do with the addresses that can be pulled and delved out to the nodes or connected devices on a network. And when you set up networking, you end up doing a lot of work with setting up IP address range. Now, this is a non-routable IP address, right? It's your local area network. It doesn't go out on the internet. Mr. Router takes care of giving out the routable IP address. So many Soho routers here start you out with an IP address like this, but they're not routable. So your router takes care of that, right? It does both of that. And that, well, I guess we're talking about it here. That has to do with public and private IP addresses. Many colleges are set up with a set of non-routable addresses in the classrooms, but those aren't routable to the World Wide Web. So the server takes care, the router, which is probably a service on the server, takes care of using an IP address that's able to do that. So this is just giving a range of addresses. And here's an example of private that fall into 3 different categories. This is the one you're going to see the most, right? Right here. That's the one you're going to see the most. 192.168.0.0. This is the low end, and then this is the high end. And this gives you, that subnet mesh you saw earlier means you got 255 nodes that be used in that subnet mask. So that you would use a different one. Instead of 192.168.0, you would go to maybe to 001. You set up the IP address. Now, a network address, okay, a NAT, a network address translation table, modifies the address that's what's in the router or the service on the server that accesses the router, and modifies the address to something that's routable. So we have an example here. We're converting a public IP address for the router, for example. All right, here we go. That's routable. That's an address that can go across the network. IP6, what happened is IP4, which is the Internet Protocol version 4, has just so many addresses that can be used, and we're running out of them. So as a standard, those engineers I talked about, the IEEE engineers, came up with another configuration of IP addresses called IP version 6. Many more IP addresses, many more that can be used, right? And here's an example. It's very hard to understand. You'll actually get tested on some of this on the the CompTIA Plus test. You'll end up working with that. And I did when I did the training with Cisco on this. So here's now this is the class 3 address. This is the subnet mask. So again, we can put a gateway in there down below, which is how you travel from segment to segment on the network. What else? Oh, there's a lot of stuff here. Dynamic IP addresses. We talked about the host assigning the IP address. So we're talking about that here. The static address would mean I'm gonna assign that address because I don't want anybody else to use that address. So again, it's put up in the high range of the IP addresses that are accessible, but not included in the range of a pool of addresses that can be assigned at will with the DHCP. Okay, network configuration concept lit up. We talked about DSM, DHCP. Virtual LAN is very, very important. That's how we set up a lot of classrooms in corporate enterprise environments. We set them up virtually, so it's just much more efficient to do that. And many times we'll have server desktop computers that don't need to be configured locally. We actually deployed when you turn them on, which we have a lot of that going on. What else? Let's see. Okay, have to do with internet connection type. So most of what we're going to see nowadays is your Cat6 cables, your 8 pairs of twisted wires. You'll see cable. Comcast uses that. It's for cable TV, and you'll also see it on manufacturing floors because there's a lot of insulation around that network cable to protect against electromagnetic interference. So in a manufacturer environment, you would see cable connecting some of those devices. DSL, that's ATT Uverse, right? So that's going with it has to go with the digital subscriber line. It has to be with a certain range of your home to be able to get to that. If you're in the outer areas of the town, you may not have access to that with phone lines. And I think here's fiber. You'll see fiber used a lot in complexes that have buildings connected together. Fiber goes a lot farther than your Cat6 cable will go. So that's very handy. Satellite, again, if you're in outlying areas, you'll need to connect with satellite. There's no Comcast, there's no ATT Uverse. Cellular used almost everywhere now, and now I'm happy to see cellular use satellite when you're out in an area and there's no cellular coverage. You can use satellite, at least on the Apple phones. Well, we'll get into the tools. I know this is a long chapter, so I apologize for that. Crimping cables. So I have a device here that lets you crimp the cables, because what you have to do is strip off at the end of the cable the sheathing around each of the 8 cables that are twisted. There's 4 pairs of 2 twisted cables, so you have to strip off the end so you can terminate them with a crimp, like you see that plugs into the wall for your phone. That cable has 4 wires. The network cable has 8 wires, 4 pairs of 2 twisted together. So this is the device that crimps them, and this is showing you cutting it. Well, not very well. This is showing you cutting and terminate the cable. Here's a punch down. So I need to put this into a wall network outlet that I can create. I can punch that down. You'll see this very handy. You may or may not be doing that part of it, checking the voltage of the wine, some testers. It's where you'll see the testers, where this will come in handy is, did you terminate that network cable? There's two different ways to match up the 8 wires that go into the crimp that goes on the end. And there's an A and B method to do that. And there's charts to show you that. I used to be most of the time, but you'd be surprised sometimes in a large deployment of a network in a larger school or enterprise environment, it's not always done consistently. You can actually check that, and you'd be surprised sometimes where they're not terminated correctly. It happens. Wi-Fi analyzer. Now this is handy for doing a Wi-Fi assessment for ability to see, well, how many wireless access points do I have to put for coverage, and how close do they have to be from each other, and what items are interfering with the wireless transmission of connectivity for the nodes. Are there metal walls? Are there microwave ovens near the kitchen that interfere with the signal? Are there wireless phones that use the older transmission method? How many people are in the local area network that are taking up space? Because surprisingly, water interferes with wireless transmissions, and people are made of a lot of water, and that I was at the Moscone Center in San Francisco for a Google I/O event, and we had a lot of people. I think we had, oh gosh, I think around, I don't know, 3,000 to 5,000, and we had access points we were using, and we could not get connection. There were just too many people in the building. So this is just showing you some of that. And that is chapter 2. It's big, and I'm probably going to have another week of coverage in networking. Try to get through it. I hope this makes sense. I hope it was helpful, and I'll try to keep the lecture shorter in the future. So good luck. All right, I'll stop for now.